We have kinetic energy that started at 1,000 joules once the skier has reached the flat portion of the snow and ended at 200 joules a little while later. The first question deals with the kinetic energy itself. If the kinetic energy goes from 1,000 joules all the way down to 200 joules, what must be happening? Well, his mass isn't changing, and we know that kinetic energy is 1/2 mass times velocity squared. So if this first bit stays constant, then the decrease in kinetic energy must be due to the velocity alone. So if your velocity decreases, your kinetic energy must also decrease. So therefore, velocity must be dropping. In part B, with the skier sliding on a flat surface, is there any change in gravitational potential energy? Well, gravitational potential energy's formula is mass times gravity times height, which means, therefore, your change in gravitational potential energy would be mass times g times change in height. And since there's no change in height, that equals 0, that would mean your change in potential energy is also 0. So he stays at the same level, no change in potential energy. And in part C, how much energy was lost due to friction? Well, as he skis along, there are some losses. Now we're assuming all the losses in this case are due to heat from the skis and the snow in contact with each other. But there would be some minor losses due to sound and a few other things, deforming the skis and things like that. But if we assume a majority of those losses are due to heat, if his initial energy was 1,000 and his final energy was 200, if I subtract those two, the missing energy must be the energy lost due to friction on the ground, due to heat. So this energy that was released into the atmosphere ends up being 800 joules.